See you both. Happy Hump Day, Wednesday. Remember, tomorrow is Win Day, so if you need any help, we won't have any live classes for science, but if you need any help, I'll be available. So, how about you, Jalil? Are you doing okay? Everything going all right for this third week? Yeah, good, good. Keeping up with your grades, I hope. All right. Hey, Christian, how are you? All right, so you guys are doing okay. Well, we've got a few people here. Three people. All right. So, well, anything happening? You guys gonna do anything? Anybody got a birthday this week or this month, February? I have. Anybody got a birthday? Any birthdays this month for you guys? I know there's only three. Hey, Mariana. Oh, really, Madison? Well, happy birthday. So now you're able to drive now, right? Old enough to drive, right? Or am I making you too old? Oh, excellent. So have you been taking driver's tests? Driver's practice? You have one of those schools, those driving schools? No, okay. Hey, good afternoon, ladies and gentlemen. Hey, Ariana, Austin, and Zaria. Anybody? Madison had a birthday on the third. We should have had said happy birthday to her. I missed it. Sorry. Sure, not a thanks for telling me. Oh, I got you, Mariana. All right. Not anybody else have a birthday? Oz, when anybody have a birthday in February? Bradley, anybody birthday this month? So Madison had a birthday. Mine is on the third. Oh, you what it was on? Oh, July. Oh my gosh, you're almost a firecracker. Hey, Rihanna, how are you? Good to see you. I have a brother that has his birthday on the 4th. He's a firecracker, that's for sure. Hey, Jasmine, anybody have a birthday in February besides Madison? Madison's birthday passed, so should have said happy birthday. If we had cake, we'd give you guys all cake. Some people don't like cake, but I do. I still like cake. All right. Well, good to see you guys today. We are going to be working on acceleration calculations. So this is what we're doing today, the calculations part. Don't worry, I've got your back. We've been talking about acceleration this week. Acceleration is the rate of change in an object's velocity. So remember, you can experience acceleration. Remember when your brother or your dad or whoever's driving speeds up, you're being pushed back. You can feel acceleration. You're speeding up. You can't hardly, if they're really going fast, it's hard to sit forward. And then if they slow down really fast or stop hard, you go forward. And if it wasn't for that seatbelt, you'd be out the window. So thank goodness for seatbelts. And then if they turn the corner, you feel acceleration there because acceleration, all you have to do is change direction and you can feel it. You can feel it moving you from side to side. So acceleration is a vector, right? And you really need to know this part right here, meters per second squared or meters per second. So it looks like velocity meters per second, except for we're saying meters per second every second. So if I were to draw you pictures of constant speed, right? Constant speed is when we're not speeding up or slowing down, but we are moving. And it's kind of like when you have hit the button for cruise control, right? Cruise control, the dots are evenly spread apart. Your body's not moving. You might be bumping up and down on the road, but you're not moving backward or forward or sideways, right? So constant speed looks like these dots, but acceleration looks like these. So we're at a stop, and then we slowly pick up speed, and the dots get further and further apart, and then even further. So acceleration looks like that, speeding up the dots. If those are like photographs every second, the two dots would be close together and then further and further apart. Now, the same thing happens when you're starting at a constant speed and then you start to slow down. Then the dots get closer together until you finally stop. And that's called deceleration or slowing down. So we see that all the time because you have to accelerate even to get started, right? So positive acceleration is velocity increasing in the forward direction, right? Or decreasing in the backward direction. Negative acceleration is velocity decreasing in the forward direction, slowing down, or increasing in the backward direction. So you're going backwards and you're speeding up, right? So we saw that yesterday where that lawnmower that person drove backwards, right? So we're going to do the calculations today. So I need your help on this. If you are struggling with this, let me know. Don't, we will have some time the last half of the class to go over some things. And we're going to go over velocity assignment 2. If you didn't get that done, I have a list of names and we can do that in the breakout room. So the delta, so when we're looking at this triangle, right? So if I go, it's not a triangle, it's a square. If we have a delta, this means change in, and it's called a delta because that's the Greek letter delta, change in. So you see the triangle in front of the V, that means change in velocity, right? You can also use it for change in time. Okay, so, and remember how we do this. We take, if we want to find the acceleration, if I'm using this triangle, I cover it up with my finger and I have change in velocity divided by time, right? If I erase that and I want to find the velocity, right? I can cover that up. Then I have acceleration times the time. Okay. Right. So let's see what we got here. Let's continue going. So let's work on this one together, ladies and gentlemen. So you can pick anytime you want to. So let me go through this for you. So the change in velocity. First, we need to see the initial velocity. So the initial velocity is 5 meters per second. The final velocity is 15 meters per second, and my time is 5 seconds. Okay, so how we do this, let me get this bigger, is like this. I take my final velocity, 15, minus my initial velocity, 5. Then what I do is I take and I divide that by my 5 seconds. All right, so you should be getting a number now. So this will ends up being 10 divided by, and this is the divided by sign, just the line underneath, 5. So what do we get? 10 divided by 5, and we're going to use these units, right? meters per second squared. Okay, so we're going to type in meters per second, and I'm going to use the shift and 6 key to put that squared sign in there. Meters per second squared. All right, so what did we get? Oh, I got 4 people that got it. A couple people put 5. Thanks, Jeremy, Madison, Zaria, Renaya, Jasmine, Ariana. Anybody else want to get in there? I'm going to be doing a drawing again on Friday for free assignments. So this might be the time where I might be using your data. Okay, so the answer is 2 meters per second squared. 2 meters per second squared. 10 divided by 5 is 2. All right, and that shows us that it's accelerating for at least for the first 5 seconds. All right, so let's try another one here. So this is a little bit different. So we're looking at the change in velocity. And if you read this, it says, what is the acceleration when delta goes from 8 meters per second to stop? So this is my initial velocity, I, and stopping is my final velocity. Okay, so if I put a number on final velocity, what would it be? What is the final velocity of going to be? So I got a different question for you. So if you type in the answer, what can I put number for stop? What number can I put in for stop? Should I put 1, 2, 3, 0? What could I put in for stopping? 8 meters per second to stop. All right. Thanks, Jasmine. Thanks, Dalil. All right. Anybody else? All right. So let's work on this together. So my final velocity is going to be 0 because I'm stopped. I'm not going any 0 meters per second. Meters per second. I'm at a standstill. If you look at your speedometer on your car, it should say 0 when you are in park, or at least stopped at a stop sign. Put your foot on the brake, it should say 0. -8, right? So we've got 0 minus 8 meters per second, and we're going to divide by 4. Now you're going to get a negative number here. All right. Let me do this again. I'm going to take this out of here. All right, so what's the answer going to be on this one? What you're going to get a negative number, which means it's slowing down. So this is going to be in meters per second squared. Meters per second, shift 6 squared. Okay, so what is that? There we go. One person's got it. Thanks, Madison. How about you, Lennon? So it's -8 divided by 4. Use your calculator. All right. Thanks, Ariana. Thank you, Madison. Thank you, Jaleel. So we're ending up with -8 divided by 4, and we should get -2 meters per second squared. So -2 meters per second squared. That means we're slowing down. It is a vector quantity, so we can use negative numbers to tell us that it's slowing down, right? Or going to a particular direction, right? Okay, so -2 meters per second squared. All right, so when we're using a graph, remember, we're using the y-axis. Make sure you pay attention to this, okay? We have changed this now to velocity. We're using the same graphs, but because we're using velocity and time for the x-axis, we have to interpret it different. So that's what we're going to be talking about today. We interpret a velocity versus time graph differently. Remember, when we had a distance versus velocity, this was moving forward, this was stop, moving forward, and this was backward. And it means something different than that because we're using velocity in the graph, okay? So here's my x-axis or my horizontal axis because that's where the sun comes up in the horizon. Right, so graphing helps us analyze large sets of data. In a velocity time graph, shows the velocity of an object at different points in time. So like little snapshots. Velocity on the y-axis, that's the up and down axis. Velocity time is on the x-axis, that's the horizontal, side to side. Therefore, the slope tells us velocity divided by time, and that gives us acceleration. So the slope is now acceleration. That's your rise over run. So knowing the y final and y initial is important when you want to plug this information in. So let's take a look at this first question here. All right, so let me give you a, all right, so this is 20, right, for my y and 1 for my x. All right, so 120. Remember, it's x and y, right? So if I want to know the velocity of this, it's 20 meters per minute at one, and I took that measurement at 1 second. Okay. So let's do this one together. We're going to find the acceleration, right? So what is my y final? So let me ask you this question. What is my y final here? Whoops, I'm going to close this out. Clear this one. There we go. What is my y final? Okay, so remember we're looking at the y-axis. I'll give you a hint. It's in the circle blue. So what number should I put for y final? You could go ahead and put that in the chat. Y final. Anybody would be fine. Right? The circled blue is your final place. All right. Thanks, Phoebe. I missed you yesterday. I didn't see you. Good to see you. Thanks, Renaya. All right. So what's my y initial? And I'll give you a hint. It's the circle in red. What's my y initial? Thanks, Madison. You got it. 0. All right. Now let's look at time. Time on the x-axis. All right. So we have to look at the blue number now, but we need to have the information for that is below. So what is my x final? All right, you guys got it. And my x initial, 0. Thank you guys, you got that right, 0. So how we construct this, there's a couple ways of constructing this. I'll show you the way the slope-intercept form works. All right, so I'm going to put y final, which is 20, minus 0. That's my y final minus y initial. And then I'm going to put my x final, which is 1, minus 0. So I end up with an equation that looks like 20 divided by 1, or 20 meters per minute squared. See if I can get this over here. 20 meters per minute squared. Come on. Yeah, 20 meters per minute squared. Now, this shows us, this portion shows us speeding up. This is speeding up or accelerating, speeding up. Okay, speeding up is what we have here. Can we get that smaller so I can, here we go, speeding up. All right. Now you might have a tendency to say, I can get this to move here, this is speeding up, that this next spot is doing something. So notice, though, that it says at red, its velocity is at 20 meters per minute, and at blue, it's 20 meters per minute. So let's see what we can do with this question. So I'm going to start a poll. What's happening at that flat spot? Start a poll. The flat spot in acceleration, it says 20 meters per minute at the red and 20 meters per minute at the blue. So at 1 second it's 20 meters per minute, and at 2 it's 20 meters per minute. So what can we say is happening at that flat spot? Is it slowing down, speeding up, stopped, or is it just at a constant speed? What do you think's happening there? Let me give you the choices here. Let me start another poll here. Start a poll, and I'll give you, let's publish this poll. Let's start a poll. All right, so A, is it speeding up, up? Is it B, slowing down? Is it C, stopped? Or is it D, the same speed? All right, so let's do that. Maybe that's a little easier choices for you to think about. What do you think is happening in this flat spot? Is it A, speeding up, slowing down, stopped, or the same speed? Okay, I've got one person that's saying it is B, slowing down, two people saying slowing down. I have one person saying stopped, and I have four people saying same speed. Okay, so the correct answer, and I really appreciate you guys putting in that information, this is the same speed, right? It started at 20 on 1 second, and it's at 20 at 2 seconds. So it's like this. The first section, I'm being pushed back. I can feel the acceleration. Then you get up to 20 meters per second, and your parents put it on cruise control. Let's just go 20 meters per second, 20 meters per minute, and you don't feel anything. So that's the same speed. And what they call it for us is that there's no acceleration. There is no acceleration going on at that point. So no acceleration going on in this flash spot. And it helps you when you think about stopped, and if I like the idea of no acceleration because it kind of you think about there's nothing going on there. Stop means there's nothing going on here. Here, there's no acceleration going on here, and that helps kind of keep that going on. Okay, so flat spot, no acceleration, right? So what did we say this was? Okay, let's start a poll here. Is this speeding up, slowing down, stopped, or same speed? Let's try this again. What do you think this part here? Going from red to blue, speeding up, slowing down, or stopped, or same speed? I got 5 people. Thanks, Zaria, Phoebe, Madison, Jasmine. Thank you much. Thanks, Ariana, Lennon, and what's we got? Got somebody else. Jaleel, thank you guys. So 6 of you say it is speeding up, and that's true. Acceleration, this is pushing me back. Okay. All right. So this next part, let me do this one here. Start a poll. All right, so this next part here we're talking about. Okay, what are we saying happens here? Is this speeding up? I feel like it's speeding up, so it's pushing me back. Slowing down, I've been pulled forward. My seatbelt keeps me backing up, or same speed. All right. All right, so it looks like you guys, most of you have it. All right, this is slowing down in the forward direction. Okay, so speeding up, no acceleration, or same speed, speeding up again, slowing down, going forward. Okay. So, and let's do this last one. Let me help you let's do this last one here. Let's do this acceleration. So we know this is slowing down. So let me ask you in this question here, slowing down, is that going to be a positive number? That's A, equals A. Or is this going to be a negative number? And that equals B. B. So let's do A and B. What do you think is going to end up as my calculation here? Because is it going to be, I've got a negative number plus B. I wanted to hit the equal sign. So going to be a negative number or a positive number? Positive number is A, negative number is B, even though I got a plus B on there. All right, so I've got Rihanna and Ariana, Jasmine and Phoebe, and you guys doing great. And Lennon, okay, so this is going to be a negative number for slowing down. Okay, so let's see how that works, and let's see how we go on this one. So final velocity is going to be the blue. All right, so the blue is for the Y. That means if I go over here, I take the blue, I come all the way down here, and I notice that's 0, right? 0 for the final, because that's where it ends up. 0 for the final. And then Y over here, I'm going to go look over here, and that's 60, Y 60. So, and let's put that number in there. So 60 for my final velocity. And my final time is 6 seconds, then the blue. 6 seconds. And we're going to go here. Let's go, give me a pen mark. I'm going to go down here. So this is where we got to go. So this is 5 seconds for the initial. Okay, so let's see if we can start a poll on this one. What's my final answer? Final answer. Final acceleration, ACCEL, final acceleration for this. We're going to type us a response here. Let me help you guys out with this. So we're going to take Y final 0 minus 60, okay, divided by 6 minus 5. So our final answer looks like this: 60 divided by 1. So what's my final answer going to be? What's my final answer going to be? There we go. I got one person's got it. 60 divided by 1 is 60, right? But it's going to be a negative, right? Negative 60. Sorry, I forgot to put that negative in there. So it's going to be a negative 60. And it's going to be meters per minute squared. Okay. All right, so 60. So that is slowing down. So there's a lot of ways for velocity time graphs to work. There's a lot of information here, and let me show you. These are the demonstrations of this. The ones things that I want you to keep track of. All right. So downward above the x-axis, and what that means, if you look at this, there's the y-axis, and it goes to 0 here at this point at this spot here is 0. And then it goes, the y-axis goes to -1, -2, -3, -4. So there's a lot of different ways of, so what happens, and I'll show you on Friday with the PhET diagrams. It'll be interesting. So we're going to look at, all right, downward above the x-axis. So that is, it looks like your regular axis, right? X and Y. It says slowing down if it goes this way. Slowing down forward if it's going this way, right? Right. And number 4, upward, is speeding up. So if it goes this direction from left to right, that's speeding up. This is plus. This is minus number, so slowing down. And then finally, what we're interested in is no horizontal slope, or a 0 slope, shows no acceleration, constant velocity. It is moving, unlike when it's your position. This is the velocity. You have that. Okay. Okay, so let me, got a lot of things happening right here. So let me just kind of stop right there, right? And we'll kind of review this. But what I'd like you guys to do is I'm going to give you assignment. I'm going to help you guys with assignment 2, W2 assignment 2. It's 5 questions. If you don't look in the shared document, you'll see your name. If you see your name, you either got a low score or no score. So you can do that yourself. Remember, it's unlimited, or you can come out into the breakout room. So I'm going to put the names of the people that are below a good score, have a low score, and it could be a low score of 0 or a low score of 9 out of 15. I'll put that information, those people, in the shared notes. And then in the chat, I will put the big blue button link in the chat. Okay. All right. So give me a few minutes to get that started, and I'll be right. All right. So again, you have some things that you guys can do. You can work on the assignments that I have. Remember, W2 assignment 1 and 2 were due last week. So if you, I'm going to go over W2 assignment 2, but if you want to do 1, if you haven't done it, you can also do W2 quiz if you haven't done it. And then work on week 3, any of the bonuses. So I'm going to give you the last 20 minutes for that.